Hello, good afternoon, my dear student. Today we will solve some problems related to two-port networks. In last class, we have discussed about the conversion of two-port network parameters. We can calculate the value of y parameters of a two-port network by knowing the values of z parameter or vice versa, or we can also calculate the values of h parameters by knowing the values of z parameters or y parameter, I mean impedance parameter or admittance parameter, or you can calculate also the value of a b c d parameter. Okay, so we know that there are total four set of parameter associated with. First one is impedance parameter or z parameter or open circuit impedance parameter. Second one is admittance parameter or y parameter or short circuit admittance parameter. Third one is hybrid parameter or mixed parameter or h parameter. And the fourth one is ABCD parameter or transmission parameter. You must remember one thing, that the inverse of H parameter is also associated with with two-port parameter. I mean, we can calculate the inverse of H parameter, and this parameter is known as G parameter. G parameter. Okay, the inverse of H parameter is known as G parameter. Sometime in uh, question actually asks calculate the G parameter of a two-port network. G parameter is nothing but the inverse of H parameter or hybrid parameter. Everyone must remember this thing, that G parameter is the inverse of hybrid parameter or H parameter. And another one more parameter, that is nothing but the inverse of transmission parameter or ABCD parameter. So therefore total 6 parameter we generally consider for a two-port network: Z parameter, Y parameter, H parameter, ABCD parameter or T parameter, transmission parameter, and also inverse H parameter or G parameter and inverse ABCD parameter or inverse transmission parameter. Okay, and you have a good concept about these parameters. Okay, and you can calculate the values of this parameter. Okay, by knowing the input output port voltage, input and output port current. Okay, now we will solve some problem related to two-port networks. Okay, so let me tell you the first problem. Suppose you consider a T-time network. Everyone has a good concept about T structure or T-type network and also pi-type network or delta network or star network. So far we have discussed about this two type of network. Okay, T-type network or star network and delta network or pi-type network. Okay, pi-type network, and you know their interrelation. You can convert one network into another network. So I am telling you that everyone first consider a P-type network, pure resistive. Problem 1, you consider a pure resistive T-type network. Okay, two-port network. Consider, let me draw it, it's better to understand. Everyone must consider a pure resistive two-type network. Pure resistive two-type network. Okay, suppose we consider one resistance, we consider another resistance here, we consider third one is here. This is considered a T-type network. Okay, T-type network. Now you connect this resistance with that one. I will tell you, you consider the R values. All resistance having the same value, that is R. Okay, T-type network. No problem. Then you two-port network. Okay, this is nothing but a two-port network. So that means it has total 4 terminals. Everyone draw it yourself, and you compare your two-port network with this one. Okay, two-port network. Okay, that therefore total 4 terminals. One dash, two dash. If you consider total, and this value is resistance values is R. We consider the resistance value is R. All values are same. R. Okay. This one also R. Everyone must consider resistance values R, and this one also R. Now you calculate the value of H21 parameter. H21 parameter. Here you consider the voltage is V1. Here you consider input port voltage V1. Port 1, I mean not input output. You can interchange this thing. You can consider the right hand side port as in input as you like. So that's why you just write port 1 and port 2 voltage V1 and V2, and you consider the current is I1 current. Okay, and port 2 current is I2 current. I2 I2 current. Okay, so this is a two-port network. Now you calculate the value of calculate the value of H21 parameter. H21 or H12, whatever I have given here, H21 parameter. Calculate the value of H21 parameter for this given network. Parameter for this network, for the given network. Okay, given network. Everyone calculate it. H21 value, you know that there are total there are total uh, 4 age parameters: H11, H21, H22, and H21. Okay, there are total 4 parameters associated with H parameters, set H11, H12, H21, H22. So here I am asking you calculate the value of H21 parameter for this network. How do you calculate the value of H21 parameter? So you first you need to know the expression of H21. You see 2 and 1. So subscript is 2 1. That means, and you know this is a mixed parameter associated with voltage and current both. Okay. So that means it will be, you can write I2 by I1 when V2 equal to 0. Okay, let me write the first. Everyone write the network equation in terms of H parameter. The network equation in terms of H parameter, let me write it here. The question is that calculate the value of H21 parameter. So we know that for H parameter the independent variables are V2 and I2. V2 and I1. V2 and I1. I1. V1 and I2 are dependent variable. You know that. V2, V1 and I2 are dependent variables. For this case, we have prove it. Dependent variables. And I1 and V2 are independent variables. Okay, you know it. Then you can easily calculate the relation network equation for this variable. So we can write uh, V1 in terms of independent variable H11 I1 plus H12 V2 I2 equal to, we can write H21 I1 plus H22 V2. We can write, this is the network equation. Now our objective is to calculate the value of H21. So from this we can write H, therefore H21 equal to I2 by I1 at V2 equal to 0. We can write it. Everyone look at the network and you write the expression of H21 from this network. So therefore we can write H21 equal to I2 by I1 at V2 equal to 0. Now you calculate the value of H21 in terms of resistance. Okay, in terms of resistance by using Kirchhoff voltage law, KVL or KCL, whatever. Generally we use KVL, Kirchhoff voltage law, for solving such type of problem. So now you tell me the value of H21. First, you tell me, anyone tell me what is the value of V2. You write the Kirchhoff voltage law for right side loop. Everyone listen to me carefully. You write the KVL equation for right side loop. This is this current entering, I2 current and I1 current also entering. So you write KVL equation for the right hand side loop, because you see V2 equal to 0. So here you write KVL equation. What will be the KVL equation for this loop? So we can write V2 equal to what we can write? Tell me. R I2 the voltage drop across this. Here I have considered this loop. That the supply voltage is V2 supply voltage, the V2 equal to the voltage drop across this resistance plus the voltage drop across that resistance, middle one. So we can write RI2 plus R, this R. What will be the current through this resistance? I2 plus I2 plus I1. This I1 current is also flowing through this resistance. Okay, we can write this thing. Everyone look at the KVL equation for loop, right side loop. Okay, we can write this thing. If you have any doubt, you tell me. So now we can write if we take common I2, then we will get 2R I2 plus R I1. Okay, this thing you know that V2 equal to how much? V2 equal to 0. To calculate H21, we have considered V2 equal to 0. That means shorted. The port 2 is shorted. Okay, the port 2 has been shorted out, so we can write 0, V2 0 for this case according to our problem. 0 equal to 2R I2 plus R I1. Now we can write H21 equal to I2 by I1. I2 by I1. If I put here I2 by I1, then I can write I2 equal to how much? I2 by I1 equal to how much? You can write minus half minus 1 by 2. This will be your answer. Minus H21 equal to minus 1 by 2. Everyone, look at the circuit. First you look at the circuit carefully. First you understand the problem. Okay, the problem is that calculate the value of H21 parameter. Here I am asking you to calculate only the value of H21 parameter. Okay, nothing else. You know there are total 4 H parameter: H11, H21, H12 and H22. Here I am asking you to calculate the value of only H21 parameter. How do we solve this problem? First we need to use the expression of H21 in terms of port voltage and current. If we write the network equation for this network in terms of H parameter, then we can write V1 equal to H11 I1 plus H12 V2, I2 equal to H21 I1 plus H22 V2, because we know that dependent variables can be expressed in terms of independent variables. Okay, so from this expression we can write the expression of H21 parameter as the ratio of output port current to input port current at V2 equal to 0, I2 by I1 at V2 equal to 0. So that means to calculate the values of this parameter, we need to consider only the output port side or right hand side loop. The supply voltage is V2. You know that this voltage will drop. This voltage will drop across resistance R in series connection and resistance R in parallel connection. Okay, I mean middle one. This is T type network. These are and that are. So this V2 will drop. So according to Kirchhoff voltage law, we can write the supply voltage V2 to port to port 2. Okay, equal to the voltage drop across resistance R I2 plus the voltage drop across another resistance R, which is the product of R and the total current, which is flowing through the resistant middle one is I1 plus I2. You see that there are another current I1 coming from the left hand side path. This I1 current will also flow through this network, and this I2 also flow through this resistance. Therefore total current is I1 plus I2, because the same current direction for both this case same, from upwards to downwards. R I2 plus I1. Now if you could take in common I2, then you will get H21 equal to I2 by I1, which will be equal to minus half. Okay, any difficulty to solve this problem? If you face any difficulty to solve this problem, you write in your chat box. Okay, anyone, if you have any confusion to understand the expression of h to 1 and the steps associated with this solution, okay, you write in your chat box. Okay, if I ask you calculate the value of h22 h22 parameter. The h22 parameter, what will be the value of h22 parameter? I2 by v2 when I1 equal to 0. When I1 equal to 0. Okay, then you can calculate it by considering the loop, right hand side loop and left hand loop, which one is required, you consider that one to calculate any values, any parameter values of any parameter, I mean values of any parameter, h11 h22 h12 h21, you can calculate yourself by considering either loop, right hand side loop or left hand side loop. You must use KVL, mesh equation. It is easy for you. Okay, so now you calculate the value of h12 parameter, then what you will get? V1 by V2 I1 equal to 0. I1 equal to 0. Okay, in the same way you can calculate the values of other parameters. Okay, you can calculate the values of other parameters. Okay, v1 equal to, you can write ri1 plus ri1 plus I2. Okay, like this you can solve. Now let me tell you, and if you have any doubt, any confusion regarding the solution of this problem, you write in your chat box. Okay, otherwise I will think that everyone understand this, the solution part of this problem. Okay, let me tell you another problem. Okay, this is also a t-type network. You consider another t-type network. Problem 2. Problem 2 to you consider another t-type network. T-type network. Let me draw it. This is resistance box actually. You consider another resistance box here, and you consider a supply voltage here. Okay, you just consider network. Now you consider a supply voltage here. Suppose this negative terminal is connected like this, positive terminal grounded. Okay, you calculate the value of z parameter for this case. First let me finish this part, then you consider you consider you consider okay, like this. Then you, this is 4 four terminal network. Then you complete it, and another terminal this side. Okay, this is a four terminal network or two port network. Okay. Now you will consider the resistance values for this case 2 ohm. This is 2 ohms, 2 ohms. Okay, and this one is 4 ohms. This one is 4 ohms. Okay, 4 ohms, and this supply voltage is 10 E1, 10 E1. That this side voltage is E1. Let me do this is E1, and that port 2 is E2, and current is I1 and I2. Everyone consider it. This current is I1, and port 2 current is I2. Okay, both current are entering into the circuit. You just make a arrow entering into the circuit. This current is also entering into the circuit. Okay, just entering into the circuit. Now your now problem is that calculate the values of parameter Z11 and Z21 for this network. Problem is that determine the values of Z Z11 and Z1 Z21 parameters for the given network. Okay, for the given network, how do you solve this problem? You see, this is not exactly T-type network, because the left arm, actually for left arm there is no resistance, but it looks like a T-type network. One branch has 2 ohms and middle one has 4 ohms, is also connected with a supply voltage 10 E1. E1 is nothing but the input port voltage, supply voltage, and E to the output port supply voltage, and I1, I2 are the corresponding current associated with port 1 and port 2. Now you calculate the value of Z11 and Z21 parameters. Now you calculate the values of Z11 and Z21 parameters. Okay. Determine the values of Z11 and Z21 for the two-port network. How do you solve this problem? So you first write the KVL equation for port 1 and port 2. Okay, and after that you solve it. You write the expression of Z11 and Z21. First, our objective is to write the expression of Z11 and Z12. Okay, then you write. So first you write the equation network equation. So for Z parameter, you know that V1 and V2 are dependent variable, I1 and I2 are independent variable. So V1 dependent variable can be write in terms of Z11 I1 plus Z12 I2, and you also know that V2 is equal to Z21 I1 plus J22 I2. Okay, these are the network equation. These are two network equation for this two-pole network. Now you tell me the expression of Z11. So Z11 you can, from this you just write here. From this expression we can write Z11 equal to V1 by I1 at I2 equal to 0. I2 equal to 0, and for this case from here we can write Z21 J21 equal to how much? J21 equal to V2 by I1, V2 by I1 at I2 equal to 0. Okay, at I2 equal to 0. These are the two expressions. Z11 Z11 V1 I1 by I1 at no, V1 by I1 I2 equal to 0. Okay, and Z21 V2 by I1 I2 equal to 0. Okay, correct. Now you solve it. I will tell you the answer. First you try yourself. Everyone try to solve this problem. Okay. For any problem associated with two-port network, you first write the expression of the concern or the desired parameters. Expression of the desired parameters. Maybe Z parameter, H parameter, ABCD parameter, Y parameter, whatever. You first write the expression of this parameter, then you solve it by considering the KVL for loop 1 and for loop 2. Okay, which one is required for solving the problem, for solving the given problem. Anyone tell me the value of Z11 and Z21. So now you see Z11 V1 by I1. So for this case V1 equal to E1 and V2 equal to E2. Okay, V1 equal to E1 and V2 equal to E2. So first you consider left hand side loop to calculate the value of Z11 because it is associated with V1. Everyone, you see, to calculate the values of Z11 parameter we need to know the ratio of V1 and I1, and you see these two variables are associated with port 1. So therefore we will first consider port 1 and we will apply Kirchhoff voltage law. So here if we apply, here you write the Kirchhoff voltage law, KVL for this case. Then what you can write? You can write E11 equal to, you can write E11 equal to 2I1. You see this I1, this the voltage across this resistance is 2I1. 2 is the resistance, so 2I1. Then we can write plus, you see 4 ohm resistance, so 4 into I1 plus I2, I1 total current, I1 plus I2, close bracket. Then you see this terminal is connected negative. Actually terminal of the supply voltage is connected with the resistance, 4 ohm resistance. Therefore this voltage will be subtracted or minus from the E1. So you can write minus 10 E1. Everyone look at the solution part of this problem. So we can write KVL equation for loop, for left hand side loop. So we can write E1 equal to supply voltage equal to 10 I1 plus 4 I1 plus I2 minus 10 E1, because this is connected. This is connected. Negative terminal is connected. The minus 10 I1 minus 10 E1. Now you solve it yourself. Now you solve it yourself. What will be the values of Z11? You can write, you can write it by solving this one. You can write it equal to, what we can write, E1, just you take subtraction 10 E1, if you take 11 E1, 11 E1 equal to, you can write E1 equal to, you can write 4 I1 plus 2 I1, 6 I1 plus 4 I2, but I2 equal to 0, 4 I2, but you see that the Z11 add I2 equal to 0, we can write Z11 equal to E1 divided by I1 at I2 equal to 0. Therefore, Z11 equal to how much? E1 by I1 6 by 11. 6 by 11 ohms. See, everyone look at the solution part. 6 I1 plus 4 I2 equal to 11 E1. Yes, correct. What about others? Other student, write your answer. Nivedita, Subham, Divyajyoti, Orkodeep, Orijit, write your answer. If you face any problem or difficulty to solve this problem, you write your confusion in your chat box. Okay, everyone try to solve it. Such type of problem will come in exam or even in different competitive exam. Okay, PSU, GATE, whatever, NPTL, everywhere you will see such type of problem. You solve it yourself and you cleared your confusion. Nivedita got 6 by 11 ohm, right Nivedita? Now you calculate the value of Z21 parameter. Now calculate the value of Z21 parameters. That Z21 equal to, you see that V2 by I1 and I2 equal to 0. You solve it. Then to calculate Z21 value, we will consider right hand side 2 because it is associated with E2. E2. You solve it. You solve it yourself. How do you solve the value? How do you calculate the value of Z21? Now you consider KVL for this loop. KVL for this loop. Kirchhoff voltage law. Okay. The E2 equal to, you can write for this case E2 equal to, you can write 4 I2 plus I1. Okay. I2 plus I1 minus 10 E1, same way we can write it. If you have any confusion, you ask me. E2, the supply voltage at port 2 equal to the voltage drop across 4 ohm resistance minus 10 E1. Okay, minus 10 E1. We can write it. E2 4 I2 plus I1 minus 10 E1. This thing we can write 4 and I2 equal to 0. You see, I2 equal to 0. So we can write 4 I1. 4, first you let me write 4 I2. Okay, then we will solve it. It's good for better understanding. I1 minus 10. E1 equal to how much? You got E1 equal to E1 equal to, you got how much? E1 means how? What is the value of E1? This equal to E1 by I1 equal to Z11. You can write E1 equal to Z11 into I1. E1 equal to, you can write Z11 I1. Z11 value how much? 6 by 11. 6 by 11. So you multiply it. You multiply it with 6. 6 by 6 into I1. You just write I1 by 11. Okay, any doubt? We can write 4I2 plus 4I1 minus 10E1. E1 equal to 6I1 into I1. 6 by 11 into I1. Okay, 6 by 11 into I1. Let me write in the bracket. E1 equal to 6 I1 by 11. Okay, no doubt. We can write it. Write it. So finally, we can write, if you solve it, I1 4 I2, so E2 V2 here you just replace, this is V2, for this case E2. So E2 by I1 equal to how much you will get for this case? For this case, how much you will get? Let me write here J21 J21 21 equal to E2 by I1 at I2 equal to 0. Therefore, we can write Z21 equal to, you tell me, minus, you just simplify it, then you will get minus 16 by 11. Minus 16 by 11. Minus, otherwise you solve here, 16 by 11 ohms. Minus 16 by 11 ohms. You just simplify here, you will get, for from here you can write this 10 I1 10 I1 and then let me solve it here. We can write E2 equal to 4I2 is 0, 4I1 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 plus, not plus, minus 4I1 minus how much? 60 I1 by 11. Okay, you can write 11 E2 11E2 minus 4I1 minus equal to, you just write 11I2 equal to 44I1 minus 60I1. Okay, we can write. Therefore, if you take the minus how much? 16, you will get 16I1 minus 16I1 you will get, you just let me write in next step. 11E2 equal to minus 16I1. The E2 by I1 equal to how much? Minus 16 by 11 ohm. You will get ultimate result. Okay. 1.45 16 by minus 16 by 11. Right. Sweetie Kumari. Okay. Correct. Nivedita. Right. R3. Okay. Correct. Everyone, other student, try to solve the problem yourself. Thank you, Sweetie, Nivedita, R3. Other student, also try to solve this problem and you write your answer. Okay. So to solve this problem, first step is to write the expression of the desired parameter. Desired parameter. Okay. Write the expression. Then you prefer the loop, left hand side loop or right hand side loop, whatever is required to solve this problem. You just check the check the voltage, which one is associated with the desired parameter. That side you consider the loop associated with that voltage. Okay, then you can easily solve the problem. Okay, so let me tell you another two problems, then you can easily you understand. Okay, another two problems you consider. Now we will try to solve a problem associated with ABCD parameter. Student, write your confusion in your chat box. If you have any confusion, write it in your chat box. Otherwise you will face problem in future. Okay, to solve. Okay, next problem 3. Problem 3. A two-port network ABCD parameter is given, is represented by its ABCD parameter. Okay, a two-port network. Let me write the equation matrix from of the equation. Okay, suppose a consider ABCD parameter means transmission parameter V1 matrix from you, right? V1 comma I1 close, then A B C D, A B close. You know that we can write either in algebraic equation from or matrix from, no problem, we can write it ABCD parameter. Then we can write V1 I1, V2 comma I2. I2 must be associated with a negative sign. For this case, current is leaving from the circuit. Okay, you must remember it. This is the network equation. I mean, two-port network equation is given. Okay, a two-port network is represented by ABCD parameter given by if port. Now the question is that if port 2 is terminated by a load resistance RL, okay, then what will be the value of input impedance? Calculate the value of input impedance. Then calculate the value of If port 2 is terminated by RL, determine the value of input impedance or input driving point impedance. Okay, input impedance seen at port 1. You just mention it, seen at port, because there are two port 1, seen at port 1. Okay, you calculate it yourself. Okay, a two port network is represented by ABCD parameters. ABCD parameters. Okay, parameter as given below. Okay, now you calculate if port 2 is terminated by load resistance RL. In quiz we will get the marks. Yes, Nivedita, obviously you will get marks for quiz exam. Everyone will get marks for quiz exam, so you must prepare yourself. Okay, you must prepare for quiz yourself, everyone. Okay, there is some marks for quiz exam. Okay, now you calculate. Okay, actually you know that network issue, what Taulik network issue? Mark me present. Okay, no problem. Your ID is appeared. Okay, uh, everyone solve it yourself. You solve it yourself and tell me the answer. I I I will give you some time to solve this problem. If you unable to solve this problem, then I will help. I will solve it. Otherwise, you solve it yourself. The present problem number 3. Actually you will face or say many such type of problems in many exam, especially competitive exam. Okay, your job exam, government or any any semi government organization. Okay, you will face such type of, you will see such type of problem. Okay, for two-port network especially, so you must solve it yourself. You try to understand the theory part clearly. Okay, it will be helpful for you in future, otherwise you will face difficulty in future. Okay, so this is the prime time for you to know everything about any topic. Okay, for your BTech course. Okay, you say the network is represented by its ABCD parameter, and the problem is that what will be the input impedance? Okay, input impedance for particular port 2. You know that there are two type of impedance. One is driving point impedance, another is transfer impedance. Driving point impedance port 1, port 2. Z11, Z22, transfer Z1 to Z21. The driving point impedance actually port 1, that is input impedance, Z11 equal to V1 by I1. Your task is to calculate the value of Z11. That will be the input impedance for port 1 for this circuit. Okay, tell me what will be the expression of the input impedance Z11 in terms of ABCD parameter. In terms of ABCD parameter, tell me. Anyone can tell me how do we will solve this problem? Any idea? Any idea? Actually, the question is that input impedance. Input impedance for the for port 2. Input impedance for port 2 means for not port 2, port 1. For port 1 means what? Input impedance for port 1. That is nothing but Z11. Z11. And what is the expression of Z11? V1 by I1. At that time I2 equal to how much? I2 equal to 0. We have just solved such type of problem. Problem number 2. I2 equal to 0. V1 by I1. I2 equal to 0. Okay. Z11 equal to V1 by I1 and I2 equal to 0. Now, what we will do, you just write its network equation. V1 I1, V1 equal to, you write yourself, A V2 minus B I2, okay, and I1 equal to, you can write C V2 minus D I2, okay. Okay, it's correct. Now you see that if port 2 is terminated by load resistance RL, that means V2 equal to, for this case V2 equal to minus RL I2, since port 2 port port 2 is terminated by load resistance RL. The voltage drop across RL will be same. RL will be same as the supply voltage. Okay, the voltage drop across RL, that means I to RL, and you know that I2 is actually outside is going outside from the network. So we can write minus RL I2. Now if you take ratio of these two terms V1 and I1, then what you will get? You can write V1 by I1, which is equal to Z11. You can write A V2 minus B I2 divided by C V2 minus D I2. Very simple problem, not a complex problem. Just you write within a bracket for better understanding, to avoid the confusion. Now we can write the value of V2. V2 equal to how much? V2 equal to minus RL I2. So, you just write not V2, you just write I2. Okay, no problem. You can write in terms of V2, I2, whatever. Okay, so you can write this will be equal to A V2 minus plus. We can write uh, B I2 equal to how much? V2 by RL. V2 by RL. V2 by RL. Okay. Close bracket. Divided by we can write CV2 plus D I2 equal to how much? V2 by RL. V2 by RL. Okay. Now you will simplify it yourself. So you will get ultimate you will get you will get uh, V2. If you take common V2 cancel out. A plus B, A R L plus, we can write A R L plus B divided by C R L plus D. Okay, and this is equal to nothing but the input impedance Z11. Okay, therefore input impedance or driving point impedance, input impedance is Z11 equal to ARL plus B divided by CRL plus D. Any confusion? Any doubt? Try to understand the solution of this problem. A V2 minus VI2. Okay, C V2 minus DI2. Okay, correct. ARL plus B divided by CRL plus D. Right, or 3. Your answer is correct. Quiz will be held in Google Meet. Yes, Nivedita, quiz. I will take quiz on Google Meet platform. Okay, I will take quiz on Google Meet platform. I will send you the link. Everyone, prepare yourself for quiz. Okay, now you see the input impedance for this network when output port is terminated by load resistance RL will be equal to ARL plus B divided by CRL plus D. CRL plus D. Orkodev, okay, good. Now I will give you a little bit not complex simple problem, but in terms of complex parameter. You will solve this problem yourself, and after solving the problem you must write your answer in your chat box. This is a T-time network problem 4. Okay, this is a complex. I will give, instead of resistive network, I will give you a reactive network, and you have experimentally calculated the values of parameter. Okay, for a reactive network. For a reactive network. This is inductance, or this is inductance value. I mean. Okay. You solve it yourself and tell me the answer. Two-port network, you must write the 4 terminals. Everyone, solve it yourself. Okay, this is a two-port network. Now you write the values of this element is 5 plus J 4 ohms. Okay, and the value of this reactive element, storing element, is 5 minus 4 minus J4 ohms. Okay, ohms, and the middle one, this one is 2 plus J naught 0. I mean, imaginary part is 0, but for symmetrical case it is confusing. It is written to confuse the student. This is nothing but 0. That means 2 ohms. Okay. Now you calculate the ABCD parameter for this network. You calculate ABCD parameter for this network. Calculate the ABCD, not CE, ABCD parameters. Values of ABCD parameter. Calculate ABCD parameters for this network. Okay, this is V1. This is one problem. What type of question will be asked in quiz maximum quiz marks? Harsraj, I will decide later. Okay, how much marks I will give for quiz. Uh, you consider you suppose at least 10 marks will be there for quiz, but maybe change. Okay, don't worry, don't actually think about the marks. i will uh, I will actually finalize how much marks I will assign for quiz exam. What type of question will be asked in quiz? I will ask a short type of question, okay, related to your experiment. Okay, for example, let me tell you one example. Give an example of a non-linear resistance, okay, or non-linear resistive element. For example, give an example of a non-linear resistive element. Okay, or let me tell you another example. For example, what will be the condition for maximum power transfer? What is the condition for maximum power transfer from source to load? Such type of question I will ask. Viva mode, not written. Viva mode, okay. Viva mode question I will ask, not written. Arkodeep transistor, yes. Arkodeep transistor I will ask. Okay, everyone, please note down the problem number 4 and you solve it yourself. If you face any problem in next theory class, you must ask me. One thing, actually, next theory class is Wednesday, means day after tomorrow. I want to take the theory class uh, tomorrow, mean Tuesday night. Is it possible? Because Wednesday I have a work, so that's why I can't take the theory class on the on Wednesday. Okay, so if possible, I can take tomorrow or Wednesday night. Okay, I will inform Seer. Seer will convey the message to you. But I am telling you that Wednesday's class I will take either tomorrow, means Tuesday, or Wednesday night. Okay, or later on. Okay, no problem. Thank you everyone. If you have any doubt, you write in your chat box and note down this problem and solve it yourself. If you face any problem, I will solve it. Let me stop today's lecture here. Okay.